Hello class, this is Mr. Goodman and this is lesson 2 in unit 3, 3.2 from standard to vertex form. Okay, so this is going to be a bigger lesson in terms of the concept itself, because what we're doing in this lesson is going to look like a really small little thing on our great quadratic flowchart here. All we're doing is we're going from standard form to vertex form. That's it. There it is. A, B, C is the standard form. The A, the H, and the K value, that's vertex form. And the way we do that is by completing the square. Completing the square is something you were introduced to in academic grade 10 math. And in my opinion, it's the most abstract, long-winded concept of the course. There's a lot of parts to it where it wouldn't naturally just happen, and you're just like, oh, I would have thought of that. No. There's not tons, but there's a bunch of spots where, yeah, sure, it makes sense, but truthfully, you're going to kind of memorize the steps more than just understand all the logic behind it, because there's a fair bit. So let's get going then. And I'm going to do this a couple times as I go through my explanation, which is I will come to a point where I'll say, listen, I can give you the explanation and I'll give it to you, or you can just erase everything that I just said and just do it because I say so. So we might do that a couple times. Let's see how it goes. I don't know if you know this, but these are often one-take affairs, so I don't do 4 takes and splice them together. This is all one go, and whatever happens, happens. So here we go. Standard form, vertex form. We're going to go from one to another. And the first thing we're going to have to understand is what a perfect square is. It's basically an equation where when you factor it, there's 2 identical roots. This equation factored results in 2 roots, which we don't have to write twice. We could just put a little square there. So, very quickly, some perfect square practice. I'm looking for 2 numbers that are the same number that add up to 8. What are those numbers, and what would they multiply to? Well, it would have to be 4 and 4. And 4 times 4 is 16. So this 16 makes this quadratic equation a perfect square, because when we factor it, that's what it becomes. Same thing here. -6 and -6 becomes -12. 36 completes the perfect square. We don't just have to guess, as I just did here. I kind of logically, it might make sense what a perfect square is. But there's a little formula that we can use that can allow us to calculate what the new C value will be that will create our perfect square. Just to recap, here is a C value. Here's the C value, and we call it C because of the A, B, and C. And we're looking for a C value that would create a perfect square. So here's the formula. B divided by 2 squared. That's it. And this can work because it's not obvious what 2 numbers would add up. It's the same 2 numbers would add up to 3. What would they multiply to? Well, it just so happens that we can take that B value of 3, divide it by 2, that's the formula right here, square it, and therefore 9/4 is what gives us our perfect square. And if you don't believe me, we would factor this, and then of course both are the same, and therefore it's a perfect square. We can do this with really complex B values. This B value here, here's the B. I put in the B value. Now this is -5/2 divided by 2, and that might be a little confusing to you, but just trust me when I say this divided by this becomes that. And then when we square it, this is the number we get. So the C value that we need for this to be a perfect square is 25/16. Okay. So, why am I doing this to you? Again, this is an abstract concept that really doesn't seem like it has any bearing on not only your life, but probably math in general. So let's now kind of get to what we're actually trying to do here. So, here is a quadratic equation, and it is not a perfect square. If that was a 9, that would be a perfect square, but it's not. When we factor it, we see it's not. So, the question really is, how can I make this 5 a 9? That's pretty much what we want to do here. And once we do that, we'll have a perfect square. By getting a perfect square, we're doing something called completing the square, which is why this process is called completing the square. Are you ready to complete the square, guys? I can't hear you because this is just a video, but I assume you're a little excited now to finally learn this, or learn this the way I like to teach it, because a lot of you have been exposed to this before. What we'll do here is we'll complete the square. And I want to point out that what I've got here is everything in purple is kind of my math that I would do if I were just writing this out. And everything here in pink is really the things you kind of have to know going forward. So the first one or two times, if you need to kind of write some notes down as you do this, then go for it. And again, I know this is a bit of a long process, but bear with me, it's super, super necessary. This isn't some sideshow thing that you might need to know. You need to know this to do quadratics. So here we go. Here is our quadratic equation, and this is our old C value. It's the one that doesn't work. We know a 9 is what we need. So we're going to put brackets on the first two terms, and we're going to calculate our new C value. And the new C value, oh, not a surprise, it's 9. We're going to put that new C value into the brackets as both a positive and a negative. Now, again, this is one of those stages where I say, you're going to take this 9 and put it in as both a plus and a negative into the brackets. Why? Because I say so. But if you're interested in knowing the deeper reason, it's pretty simple. 9 and negative 9 adds to 0. So in effect, we're not changing the value or the weight of the equation. It's still the same equation in a sense, because that does add up to 0. Now, we know we want this to just be a 9. This negative 9 gets in the way. So we're going to take the negative new C value out of the brackets. We're going to kind of just take it like this and go boop and hop it over there. Why? Well, just trust me on that. It's always going to be the negative, because I say so. If you want the deeper reason, well, two numbers that are exactly the same number are going to multiply to the C value, and that's impossible to have a negative value then be the C value, because those two numbers, if they're both negative, would be positive. So it's impossible. That one has to always come out. Okay, back to our explanation. There it is. 5 minus 9 is negative 4. We're going to factor that perfect trinomial that we've worked so hard to create. And there it is, factored. Well, we don't have to write it twice. Why don't we just write it once with a little square? And wait a second. Our A value is 1. Our H value is negative 3. Our K value is negative 4. There's our vertex. It's in vertex form. That's how you do it. I'll do this one more time. I'm not going to do both of these examples. I don't like these videos to run too long, so I'll just do this one right now. For this right here, hold on one second. Yeah, that's good. I'm just a little low on batteries, so I hope it doesn't run out. So for this one right here, I bracketed off the first two terms, and there's our old C value. Our B value is negative 8. I'm going to put into my little formula here. That means our new C value has to be 16. In goes the positive and the negative 16. And then on the next line, out goes the negative 16. It might be quicker for you to write the negative 16 on the outside, but don't do it. Put both in the brackets. I promise you, after the next lesson, it'll prevent you from making a series of mistakes that are very common. 15 minus 16 is negative 1. We're going to factor the perfect square trinomial. There they are. And we don't write them twice. We can just write them with a little square. And there we go. From standard form to vertex form. Is that easy? I hope. Maybe. I'm not going to go through this again. You can look at this and see it again, and hopefully that makes sense to you. And if it doesn't, go back in this video and to the main explanation, because they're all going to be repetitions of this. The homework for this is this sheet right here, which is, what is the title of this picture? You're going to take each of these and you're going to change them from the form they're in to vertex form. Now what I'll say here is make sure, so for example, something like this is really x squared plus 6x minus 16. This first one has to be this. You have to move everything over to one side. Make sure the a value is just a 1, not a negative 1. So make sure it's all grouped together properly in standard form, and then change it into vertex form. Do all of this. You need the practice for this kind of thing. And once you can do this pretty quickly, the next lesson will be having the a value be something other than 1. And if you understand this lesson, the next one won't be that hard. There's just a couple adds to it. And then you will have what is, in my opinion, one of the hardest quadratic concepts. So that's what it is. Oops. I hope I fit everything onto the page. I was kind of moving around a little bit. My bonus feature for the day is a picture of me at my bar mitzvah. I was 13 years old in 1994. I had to go to Hebrew school like twice a week, and I had Saturday school and I had religious school. I was studying for this bar mitzvah 3 times a week for about 2 years. I had to learn how to read Hebrew, and then be able to read it in front of, all my friends and family. And that was a lot of work, and it wasn't easy. But it helped, at least for me, in that when you have a bar mitzvah when you're 13, you get presents, and most of them are cash gifts. So and that adds up to thousands of dollars, which was then put towards my education. So that was actually motivating me. And the reason I tell this story is because you are right now working towards being more proficient in math. And it's really valuable to have some kind of motivator to move you through things. And just saying that math is good for me and I need it to get a job one day isn't enough. You need to have something a little bit more immediate. And it can be simple, like